Can you
escape
from
black holes? Let's talk about gravity.
Apparently, it's a force that attracts the body toward the earth. It's that simple, right? Okay, here's an example. So my brother has like way more mass than the dog does. Oh, it's Sugar, by the way, the dog's name. So he'll probably get pulled toward the earth way more than Sugar does, correct? The same thing applies to Sugar because she has less mass than my brother does, so she get pulled toward the earth less.
And there's this thing called gravitational field. So basically it just explains how a huge amount of body can extend into the space and then produce a force on another huge body.
And this gravitational field can be explained into a formula by Sir Isaac Newton. It is called Newton's law of gravitational force.
Okay, let me just say this. Force, which is gravity, equals to G constant times m1 times m2 all over r squared.
So G must remain constant at all times. M1 and M2 are for the masses for each object, and R is for radius.
Alrighty, let me just do one example with you guys first. How about we just let a girl weigh like 55 kilograms? For those who don't know, Earth has a mass, and it is 5.97 times 10 to the 24th kilograms. And guess what? Earth has a radius as well, and it is 6.37 times 10 to the 6, I believe. Yeah, in meter. And the constant is 6.674 times 10 to the negative 11. And then we're just gonna plug, the girl's mass and the Earth's mass onto M1 and M2. The Earth's radius, of course, goes out at the bottom. We got calculator, right? So we can just type that in, and then the answer I got was 540.06 Newton of gravitational force between the Earth and the girl.
But human is lazy, so we can just figure out another way to do it.
And that is, force of gravity is equal to M times G.
Black hole has more gravity than Earth because of its mass.
Wait, what?
Duh, gravity is all over black holes.
Basically, a black hole is just a space where the gravity is so strong that not even light can escape. In a black hole, all the matter just kind of gets squished into one single point. And that is called, the singularity. And there's this dude. His name is Einstein. You all probably know him, right? He just kind of created what is it called?
Oh, a general theory of relativity, where black holes are so huge and dense that it can cause a distortion in space-time.
Wow, I sound smart for the first time. Oh my god. Thanks, Einstein.
And here I'm giving you guys some more examples comparing to, black hole. So there's a sun and there's a white dwarf, which these two can't be compared to the black hole at all in terms of its density and mass. So there's like a really simple way to do this. Just take a piece of paper and then draw a line through it. Then you fold the paper and then you get two ending points closer together.
Maybe wondering what really is space and time. I got you. time and space are squished together as one, there's a chance that maybe there's some kind of dimension out there in the center of a black hole.
Also, all black holes have 3 layers.
So, this is like the outer layer, the horizon. Just like inside and then this is like the outside. You know, okay, what?
There are 2 layers of event horizons that gravity is still okay, but if you cross that to a singularity, then you're not okay. Sorry, but you're probably dead.
The gravity in there will kill you.
Normally, black holes have a mass of 25 solar masses and above. Solar mass stands for a huge unit of 2 times 10 to the 38 kilograms, which is super huge. But again, our planet only weighs 5.97 times 10 to the 24th kilograms. So if a black hole has more mass than the Earth does, and more gravity, then it probably has much higher escape velocity. Speaking of which, escape velocity is just a speed that you need to be traveling at in order to escape from the gravity pull of each planet. I've got the ball right here, and I'm just gonna give you guys a little demo, okay? Remember, the escape velocity for Earth is only about 11 km per second. So, if you want to throw a ball up to space, you have to throw it at a speed of 11 km per second. But I really didn't try.
And my guy right here, John Glenn, was the first to escape the gravity pull of Earth.
Woo-hoo!
You may question if we can actually travel at a black hole's escape velocity. Well, no. It's because the black hole's escape velocity is much higher than the speed of light. So far, nothing can go faster than light. So if you fall into a black hole, best believe you'll get crushed into like a wonton noodle or like, you know, a single piece of spaghetti or whatever you want to call it, just noodles. Your pieces will be added up to the radius, which is going to make the black hole bigger.
Tragic.
So my conclusion is,
You cannot.
Escape from any black holes ever.
I'm sorry to upset you in any way.
Past 100,000 miles, I'm feeling very still. And I think my spaceship knows which way to go. Tell my wife I love her very much, she knows. Ground control to Major Tom, your circuit's dead. Okay, that was really weird, but I figure I put it in there. Why not?
Thanks for watching. I hope you at least enjoy, even if you didn't understand it at all.